I don't see any distribution on these. That's okay. I mean, it'd be okay if there was as well. And, you know, I like to just start with one of them. So I'm going to go to this negative 6x plus 7 is greater than or equal to 25. And just solve it. This is a two-stepper right here, so subtract 7 from both sides. I'll try to make that a little bigger. Subtract 7 from both sides. That's isolating the x's, right? So this gives me negative 6x. My 7 zeroes out just like we wanted it to, is now greater than or equal to 18. It's positive 18, but yeah, here we go again. We're dividing both sides by a negative, which then gives me that x, that negative is going to flip that inequality, so x is now less than or equal to negative 3. All right? So that solves that inequality, but now we have this other one, and just a little bit of extra work, not really too much, but just a little bit. So I'm going to do two principles of equality in one step here. Hopefully that's okay. I'm going to put my x's on the left and the numbers on the right. And the only reason I'm saying is because I got x's and numbers on both sides of the inequality, right? Now, you could put the x's on the right. It's not going to matter. You should end up with the same inequality one way or the other. But right now, the negative 4, it has to go because it's on the x side of things. So I'm going to have to add 4 to both sides. It's going to zero that out. I'm going to get 14. Also, I'm going to have to subtract 2x from both sides because the x's are on the, those two x's are on the number side of things. So 3x's minus 2x's is 1x left over. And yeah, we'll just make that a phantom one. That's done right there. So now x is greater than 14. Now, because I don't know how the graph is going to look, I'm still going to put an or statement in between these two just to make sure that if I need to change it in the end, I can get full credit and I won't forget that or statement. I'm saying that because I usually do. I don't know if you do, but I do. So now I'm ready to graph this thing. And so you see 0 right there in the middle. 14 would be way over here, and then I guess negative 3 somewhere in this area. Doesn't have to be exact when you're doing it by hand. And yes, you never have to do it by hand on canvas as far as I know, but whatever. So x is greater than, I'm sorry, x is less than or equal to negative 3, so that's going to give me a closed circle at negative 3. It's not eating the x, so the line goes to the left. So that is that part of the graph. X is greater than 14. It's not equal to 14, so it's going to be an open circle, and it's eating the x, so it goes to the right. So that is my graph. So this is usually what our or statements look like, okay? They don't have to, just like we saw in the last example, but for the most part, they generally tend to look like this, okay? So what is my interval? Well, looking at the red line, I'm starting with the red line because it's furthest to the left. It goes all the way to negative infinity, and then it stops at negative 3, which is included, so I have a square bracket. And then I will unite this with the purple line, so that's 14, but it's not included, so it's just a regular parentheses. That's going to go all the way to infinity, and that right there is the interval, okay? So since it didn't give us one of those unique scenarios, and the interval's good, and then the original, I know the boxing here is kind of sloppy, but it works. But that's the interval, and also the inequalities, and then the graph there at the bottom. So just a quick hypothetical here. If that was an and statement, then our interval would be
none.
Yeah, it doesn't exist because there's no intersection.
So
there has to be
no
some
here.
form of intersection.